Syifa? Halo Syifa.
Halo ya Kak.
Syifa, ini udah aku bikin live di YouTube. Apa namanya? Ini aku harus ke dokter nih, Dek, bawa anakku. Jadi ini aku langsung kasihin Syifa sebagai host ya.
Oh iya Kak, oke.
Oke. Nanti kalau mau multiple share screen bisa kok. Nanti kalau di apa namanya? Di Syifa buka Zoom-nya di laptop itu kelihatan kok nanti ketika Syifa sudah jadi host, nanti di bagian share itu diklik kanan apa klik aja di situ nanti bisa klik di multiple share screen.
Oke, siap Kak.
Tapi aku pastikan Kak Syifa bisa dulu ya sebelum aku live ya.
Oh iya.
Ini aku jadiin Syifa ini dulu. Host dulu. Oke, udah aku jadiin host. Kelihatan nggak ini?
Ya, udah kelihatan.
Ada bisa bikin multiple share screen kan? Share screen kan?
Ya, bisa.
Oke. Aku live ya.
Ya, makasih ya Kak.
Yuk. Kalau ada apa-apa WA aja ya. Ini aku bawa HP kok. Oke.
Oke. Heidi.
Halo, Chef.
Ini udah masuk YouTube ya, BTW?
perlu Anda pahami. Halo Kak, tes. Suaranya jelas nggak Kak?
Jelas, Tir.
Oke.
Hello.
Tuku paketan, ambil tuku.
Ambil yang minum.
Mana?
Hello. Okay, are we live already?
Hello guys, happy weekend. For the Synbio Talk tonight, we will start in the 7 p.m. in the West Java in Indonesia time. So guys, don't forget to fill the absence and then to change your background. Because we start in the 7 p.m., maybe just 9 minutes again. Baik teman-teman, sebelum dimulai, mungkin teman-teman bisa mengganti background-nya dan juga bisa mempersiapkan diri karena kita 8 menit lagi akan dimulai untuk talk kali ini. Jadi karena talk kali ini itu berbeda dengan talk sebelumnya, karena narasumber kita ini langsung dari Prancis, tentunya nanti untuk proses acara ini akan menggunakan bahasa Inggris. Jadi nantinya it's okay jika kalian ada beberapa pertanyaan, nanti akan kami sediakan media untuk kalian bertanya. Jadi untuk sekarang 7 menit lagi teman-teman bisa untuk mengganti background dan juga untuk mengisi link absensinya di kolom chat. Mungkin sebelum dimulai teman-teman ini semuanya berasal dari mana? Mungkin kebanyakan apakah yang mengikuti tim BIOS atau mungkin ada yang dari luar, mungkin ada salah satu dari kalian yang mau memperkenalkan diri, 1 orang atau 2 orang. Atau semua dari teman-teman ini yang ikut dari lomba BIOS ya? Mungkin di sini ada yang ingin memperkenalkan diri, salah satu dari peserta yang mengikuti talk kali ini. Sambil kita menunggu. Oh, it's okay. Untuk perkenalannya bebas aja, mau dalam bahasa Inggris atau tidak. Silahkan saya beri kesempatan untuk Kak Ciko Xavier.
Oke. Baik. Halo semuanya. Perkenalkan nama saya Synbio Xavier. Sorry, my camera is not working properly. I'm from University of Indonesia. To be more specific, I'm from Synbio UI. Hello, everyone.
Yes. Okay. Thank you for your introduction. Oke, gimana teman-teman yang lainnya? Seberapa excited nih kalian untuk mengikuti talks kali ini? Karena talks kali ini itu benar-benar beda dan kita baru pertama untuk menghadirkan speakersnya langsung dari luar negeri. Dan pastinya ini juga akan berguna banget informasinya, apalagi bagi teman-teman yang mungkin terlibat di BIOS, di BIOS lomba-lomba ya. Makanya nanti teman-teman jangan sungkan untuk bertanya. Jadi nanti ada media yang sudah kami sediakan. Kalian bisa lihat di kolom chat. Ini kalian bisa memberikan pertanyaan di sana. Nanti beberapa pertanyaan yang memenuhi persyaratan nanti akan kita tanyakan langsung ke narasumbernya. Dan bagi teman-teman juga kalau misalkan ingin bertanya langsung, boleh nanti mengangkat raise hand aja, nanti bisa diberikan kesempatan oleh moderator nantinya. Okay, 3 minutes again to start. Don't forget to fill the absence in the chat below because it's very important for the next Synbio talks again.
Hi, can you hear me?
Yes, of course.
Yeah, nice.
Okay, 2 minutes again to start. Everyone, don't forget to change your background and then fill the absence in the chat below. Okay, because right now in 7 p.m. here in the West Java in Indonesia. Okay, Assalamualaikum warahmatullahi wabarakatuh. Happy weekend, everyone. Welcome and thank you for joining this Synbio Talk. I'm Tiara Rahayu as Master of Ceremony today. And then Synbio Talk is one of event in Synbio ID to focus discuss about synthetic biology, and we have goals to expanding knowledge and connect researchers around the world among student and early life scientists in Indonesia. And the aim for this talk is to introduce iGEM and research conduct in synthetic biology to bias competition participant and the public. And the output this talk, the webinar participant can gain insight about iGEM and research conduct in Synbio. So guys, don't forget to follow at synbio.id, synbio.id. Don't forget to follow and maybe to subscribe this YouTube because this Zoom can link with the YouTube. And yeah, because today is the new guys here because from the abroad. So who is the speaker? I think all of you know about that. Yeah, the speakers is the team iGEM Toulouse. So this talk will lead by moderator Ms. Martin Nohamunada. So because don't forget guys to fill the absence, and if you have the question, you can fill the in the chat below. Okay, how excited today because it's a very interesting moment because Synbio Talk is first to can with the iGEM tools from France. So Ms. Martin Noha Munada, for Ms. Martin, time is yours for the leading and being the moderator for tonight.
Yes. Hi, everyone, and thank you, Tia, for the invitation. I would like to say welcome to everyone online. So my name is Martin, and I will be your host today. And at the moment, I'm a PhD student in DTU Biosustain in Denmark. And it's been 6 years since I participated in iGEM. So I still remember vividly the
40
passion and
participants.
excitement.
Oh, damn. This thing is a success. Fuck,
Sorry.
where is Nelson Chandra?
Okay. So yeah. So basically today we will have the Toulouse iGEM team. So greetings. And as many of you know, iGEM is one of the most prestigious competition in biotechnology, specifically in synthetic biology. And it brings young talents from different fields to solve many challenges that the world is now facing using synthetic biology. And today I would like to greet Marco and Thomas. I hope I pronounced that right, from the iGEM team in Toulouse in France. And actually, they're the grand prize winner for last year's iGEM, if I'm not wrong. So, hello, Thomas and Marco. Is it just the two of you today?
Yeah, it's only the two of us.
Okay, cool. So, it's really nice to see young faces. And are you in the undergraduate track or the overgrad track at the moment?
Oh, so for this year, we are not in competition. It's another group because in Toulouse, we have only one team that just lasts for 1 year. And after that team, it's a new team. So yeah, we were the team of the 2021 competition. There is a new team for 2022. And we were in the undergraduate. We were undergraduate, if I remember. So the way that it is.
I see. Yeah. Okay. I see. And I guess you just started working in the lab, right?
So for the new iGEM team that start to work in the lab in July, and they end between August and September. But yeah.
So yeah, I mean, I'm guessing that it's nice and sunny in France, but this team will spend the whole summer working in the lab, right?
Yeah, so, unfortunately, we lose one vacation. Yeah, that's background.
Yeah. So yeah, I'm just curious. What brings you to iGEM? Why do you want to spend your summer holiday in the lab working to solve a project?
Maybe Margot, you can start.
I'm sorry, I have some issues with my microphone, and I don't have the ID of this meeting. I'm sorry, I can't reply now, but please can I have the ID of this Zoom meeting so I can have more time to respond.
Okay. Yeah, no worries. But basically, we're quite excited to hear more about your project that you're working on right now. And this competition is the one from Synbio ID. It's one of the synthetic biology community in Indonesia. And a lot of students interested to join iGEM. But of course, it's a privilege. It's not easy to build an iGEM team, right? So from the community, we're trying to build this national competition that people can join without It's not really that expensive, so everyone can join. But of course, we would like to hear more about your project, maybe a little bit introducing about iGEM and yeah. But I guess without further ado, I'll just give the time to Thomas and Margot to present their iGEM project.
So Margot, do you want to share the presentation or I will go for it?
Please go for it.
Okay, just a moment. Up. Up. Soon. So do you see the presentation?
Yes, we can see it clearly.
Okay.
All right, let's begin. I'm sorry for the little delay. So hi everyone. Today with my teammate Thomas, we will talk about our project for the iGEM 2021 competition. Our project is called Elixio, and before talking more about our project, I will explain you how the competition works. Thomas? Oh, all right. So iGEM stands for International Genetically Engineered Machine, and it started in 2003 at the MIT of Boston. You can change the slide, please. At the MIT of Boston, and the teachers challenged their students to make flashing sets, and the students really loved this experience. So the competition was repeated the year after, and in 2005 the competition became international. And since then, the number of participants has grown steadily. And in 2012, the iGEM split from the MIT and became a non-profit organization. The iGEM competition is a bit like the Olympic Games of the synthetic biology. It is a showcase for the best university in the world, for example, Oxford or, of course, the MIT. And in 2021, the competition gathered 350 teams, which represent more than 7,000 participants spread over more than 40 countries. For our team, the iGEM 2021 Toulouse team was composed of 6 students, and it is a small team, so we have to split the roles. So we were in charge of 2 main roles. Each student were in charge of 2 main roles. For example, Thomas was the wet lab leader, so he has to take care of the experiments. He has to make the experiment goes well during all the summer. And he was also a human practices leader, but we will talk about this aspect of this project later in the presentation. And for my part, I was the entrepreneurship leader, so I have to implement our project in the real world and to know if it can work in the real world. And I was also the wiki leader. And the wiki is a website where we compiled all of our results. And during the summer, we all took part to realize the experiments in the lab. And now I will let the floor to Thomas, who will talk more in details about our project.
Okay, so thank you for the introduction, Margot. So yeah, I will explain more about the project that we developed, designed, and we carried until the Jamboree to the end of the competition. So for our project, we focused on one topic. It was nude flowers, So as as it was written, so it is the flowers from which it is nearly impossible to extract the main fragrances. So, but by that we mean that it is too much money consuming for a company to extract them, or they are in so small quantities that it is not profitable for a company. So there is many examples from that. There is a lily, the hyacinth, and one flower that interested us a lot, which was the violet, because the violet is a symbol of our city, Toulouse. So nowadays, what it is used to produce, nonetheless, this molecule, it's petrosulfate compounds. They are chemically synthesized in really harsh conditions. So it is not suitable. It is really energy-consuming process, and it can obviously it cannot be labeled as natural. So we try to make the process of production of those molecules more greener with our project. So to do so, we focused on 6 main molecules that are really that are the main molecules for the violet flowers. So there is the alpha ionon, the beta ionon, the dihydrobeta ionon, and the linalol that are a family of molecules called the terpenes that are produced by one of the pathways called the mevalonate pathway. And there is another group of molecules, so it's C9 aldehydes, and they bring more how can I say that? A green, the leaf of the violet. So it's the nonadienal and the nonadienol. So we try to produce those molecules by synthetic biology. So to do so, we imagine microbial consortium, microbial consortium between a yeast and, so here is a yeast, Saccharomyces cerevisiae, and cyanobacteria, so Synechococcus elongatus. By that, we try to aim a consortium between a heterotrophic module and a, heterotrophic module and an autotrophic module. So our autotrophic microorganisms use the CO2 from the environment and the one produced by the yeast. And with that, it produces the sucrose and the O2 needed by the yeast to produce the terpenes of interest and also to grow, actually. So by that, we don't use some compounds, chemical compounds, but only the CO2 from the environment, that's one produced by the yeast to produce our molecule of interest. So it's a way more green way to produce the chemical compounds. So when we enter more in details in the pathways that we have to clone into our microorganisms, as you can see, the mevalonate pathway is divided in 2 steps. So which is divided in more steps with enzymatic reactions. But as you can see here in the native pathway, acetyl-CoA is transformed into 2 main precursors that interest us a lot. So the GPP that can be transformed into linalol, so one of the molecules of interest, and the FPPs that can be transformed into GGPP, and after that, in more enzymatic steps into lycopene, which is this red which gives this red color to the yeast at the end of the cloning. Because lycopene is the main precursor of alpha ionon, beta ionon, and dihydrobeta ionon. So actually, when we come at the lab, we take advantages of one strain that was already cloned to produce lycopene, which was made in a laboratory next to our place where we experiment. So we have only to focus on the production of linalol and alpha ionon and beta ionon and dihydrobeta ionon from lycopene. So we have to clone 6 enzymes in the end. So what is the particularity of this enzyme and our construction? So what we try to do is to bring closer, for example, the substrate and the chemical from the enzymes, because LCYE, as you can see here, which is needed for the production of epsilon carotene, is a membrane protein. And so we put a linker between LCYE and of CCD1, which is needed for the production of alpha ionon. So we try to do so also for the production of beta ionon, so with the CRTY and PHCCD1. But we also try to make a more easy construction with no fusion between the 2 enzymes, because it has never been shown before that this fusion work. So we only add phenol core to always bring the substrate from the production of CRTY to PHCCD1, so also at the membrane. So for the loosely for the construction, so for the plasmid, we try to produce this molecule in an inducible manner. So to do so, we used, as shown here, so the construction of the plasmid, so the fusion SEYE with of CT1, and we put it under a regulated promoter, so GAL1, to make sure that we produce only the quantity of interest that is needed to get the perfect order of violets. So yeah, and we try obviously to integrate them in the genome of the yeast with a two integrative site upstream and downstream of our construction. We do the same with the linalocentas for the production of linalol and DBR1 for the production of dietrobeta-ionone. And we put beta estradiol promoter and copper promoter that are also regulated promoter, positive regulated, yeah. So also in so other site of the genome of the yeast. So as I said before, we try to do so also for the production of so the beta-ionone with one construction with a fusion under TET-O promoter, so upon the addition of doxycycline, the media of culture, and here the same construction but without the linker between CRTY and PHCD1, but with an anchor. Okay, so that's why, and so that was for the yeast, but we have also to produce the molecule for the cyanobacteria, in the cyanobacteria as a CRC, so it was a C9-aldehyde. So we take advantage of the natural pathway to the natural precursor into the cyanobacteria, so it naturally produce. Sorry. So just for here, no, it's before the cyanobacteria that we take advantage is the cyanobacteria that has been engineered to produce and to excrete a lot of sucrose into the media of growth for the microorganisms that grows with the cyanobacteria. So the cyanobacteria has already been designed and engineered to be used as for co-culture with other heterotrophic microorganisms. So that's the slide that I already tried to present. So as I said, yeah, the main precursor of the pathway to produce our C9-aldehydes are already present and produced in the cyanobacteria, and is the alpha-linolenic acids. So we only have to clone two enzymes, so the 9-LOX and the 9-HPL, to get both isomer and one enzyme that is already present in the cyanobacteria, the ADH, to produce from the non-ADNL the non-ADNol. So yeah, that's the construction for the cyanobacteria. And so yeah, as I told before, we put everything under regulated promoter and also regulated translation, because here we take advantage of the BioBricks, of 9-PTG regulated promoter, but also with theophylline riboswitch for the translation. Okay, and so we also try to integrate them into the cyanobacterial genome. So I will let Margot present the results that we have during the 4 months of experimentations.
Thank you, Thomas. I will begin with the cyanobacteria growth. So we try to handle the cyanobacteria culture. And as Thomas said, our cyanobacteria strain can produce sucrose and can grow at a very high rate. And despite all of our experiments, like we tried to grow the cyanobacteria in flask and even in a bioreactor, we couldn't reach the growth rates stated in the literature. And concerning the sucrose production, we did successfully produce sucrose with the cyanobacteria strain, but also in much smaller quantities than in the literature. And we think this much lower rates and much lower production is are due to lock on the cyanobacteria culture, because we didn't have access during the summer to specialized equipment for cyanobacteria growth, but we we successfully carried growth culture of the cyanobacteria. Then we tried to grow our yeast on the co-culture medium to know if it can grow on this medium. So the co-culture medium consists of a standard medium for the cyanobacteria, which is supplemented with yeast nitrogen. And with this experiment, we proved that the yeast can grow on this medium, supplemented with sucrose at a concentration equivalent of the cyanobacteria can secrete. And previously, we proved that our cyanobacteria can secrete sucrose. But however, due to the lock on the cyanobacteria culture, we couldn't manage to grow the yeast and the cyanobacteria in the same medium. Concerning the molecular biology, we designed all of our genetic constructions before the summer, and we successfully assembled all of our construction during the first month of the summer. And during the 2 last months of experiments, we successfully integrate all of our construction in the genome of the yeast and the cyanobacteria. So we were really happy of all of these works, but it is now time to produce and detect the molecules of interest. Before using HPLC and GCMS, we only observed our strains, and we noticed something really promising. Our wild type strain of the yeast is red because of high lycopene concentration in this strain. And when we cultivate our strain on the plate containing the white inducer, the strain became more orange. And we think it is due to the conversion of lycopene into carotene, and the carotene is more orange. And above that, we also noticed a change in the smell of our strain. Our plates had a sweet smell that reminds us the violet smell. So we were really happy of these results, but it is not a proof of the production of our molecule. So we first wanted to prove the production of the carotenes. And to do so, we extracted the carotenes present in our cells by lysing them in acetone, and we analyzed the supernatant with HPLC method. And as you can see on this graph, for all strains studied, we noticed a decrease of the lycopene peak with the strain containing the right inducer, and an appearance of a carotene peak. So we proved the production of the carotene, which is the ionone precursors. And now it is time to show you the most interesting parts of this project. So it is the ionone production. The ionone are the main molecules responsible for the violet sense, and with a GCMS analysis of the culture the supernatant of our culture, we successfully proved that we produce the beta and alpha ionone. On this graph, you can see at the top, it is the standard for the alpha ionone. So we know the retention time of the alpha ionone. Then it is our yeast wild type, so without genetic construction. Then it is our modified lycoyeast, but without the inducer, here the galactose. And finally, the lycoyeast with the violet construction and with the right inducer. And we can see a small peak corresponding to the retention time of the alpha ionone. So we proved the production of alpha ionon and also beta ionon, but it is not shown on this slide. However, due to a lack of time, we couldn't prove the production of the aldehydes and the linalool because the method we used, the aldehydes and the linalool had the same retention time as our solvent. And finally, the last molecules we have successfully produced is the dihydrobeta ionon. And to prove this production, we carried out an enzymatic activity test of the DBR1 enzyme. So we lysed the cells that produced the DBR1 enzyme. And with this crude extracts, we tested the enzyme activity by adding the substrate, which is the beta ionon. And we took two samples, one before adding the substrates and one after 1.5 hours of experiments. And as you can see on the graph, for the T0 sample, there is no dihydrobeta ionon peak. And however, for the sample after 1.5 hours of incubation, there is a small peak corresponding to the dihydrobeta ionon. And this result is the most promising because in addition to produce the dihydrobeta ionon, we also proved that our fusion enzyme DBR1 is active, and this result hasn't been shown before in the literature. So this is all of our results that we had in the lab for the summer, and we were very happy to have successfully produced 3 molecules out of all of our panels. And now Thomas will talk more about the dry lab parts of the project.
Okay, thank you, Marco. So what is really important into the iGEM competition, what they try also to push forward also, it's the dry lab part. So to design a model to answer to a question. So the questions that we found that it was the most interesting for our project. It was to how to develop a microbial consortium of stable microbial consortium, and also that carries the most production of our molecule of interest. So to do so, we have to focus on 2 parts of the model. So what are the parameters outside of the cell? So for example, the CO2 concentration, but also the light also, and every parameters outside the culture, and as a parameter inside the culture. So by that I mean all the flux into a cell, so all the metabolic steps that happened. So to do so, we take advantage of 2 models. So the first one is based on differential equation, or ordinary differential equation, to translate all the outside parameter into equations. And for all the metabolic steps, we take advantage of the GSM, so it's a genome scale model, so it corresponds to each enzymatic step into a species. And to make it dynamic, we use the FBA that transform it into matrices, and after that, with the stoichiometry, it transforms it into the equation also. So it makes a dynamic model over the time of the culture, of the co-culture. So as a result of those models, as you can see here, for the growth of the cyanobacteria and the yeast, it is predicted that when we carry this co-culture together of the 2 microorganisms, both of them grow. For the sucrose production, you can see an increase of the sucrose secretion, and after that, stabilization into the media of culture because the yeast the yeast is eating the sucrose, and the cyanobacteria is producing the sucrose for it. And what is really interesting and really good for us is that we found that the model predicts that we will produce also a high concentration of our molecule of interest, and that the CO2 produced by the yeast will be used by the cyanobacteria. So over 3 weeks of co-culture into 180 liters of flat panel reactor, we found that we can produce 434 grams of fragrance ingredient in this batch. So we are pretty happy with this result, and we try to go further and also to find how to improve the co-culture. We saw, as I said before, there is many parameters, and so to understand the influence of each parameters on the co-culture, we use MCA, so for metabolic control analysis. So it looks at the influence of a parameter into a metric. So the metrics that we were interested in, it was the production, the time of production of our molecule of interest. So so the influence is translated mathematically by a coefficient value. So it means that if you have a coefficient value of 2, it means that you double the time of the needed for the production of one concentration. So it's bad, actually. So what we found really interesting is that when we design our models and with this MCA, we found that the yield of production of sucrose is a really limited step. It means that we should have not a lot of sucrose in our media of culture. As you can see, it's a violet, so it means that it's really not good for the production of the molecules, actually. So it was a really surprising result, but we tried to find out if it was really relevant, and we find that, yeah, actually by decreasing the concentration of sucrose, we produce more molecules of interest. So I will directly let you with Margot on the entrepreneurship side of the project.
Thank you. So as I told during the introduction, the entrepreneurship part stands for implementing our project in the real world as we manage a startup. So first, during this part, we started by analyze the changes related to our projects. So we compared all of the different existing production methods for violet fragrances. So they are the chemical means, natural means, and of course the biotech means. And to prove the biotech method is viable, we constructed a life cycle for each method of productions. And then we had to analyze the market needs in order to have a marketing strategy and to position ourselves and to analyze the quantity we have to produce. Yes. And with our sponsor, our main sponsor, Roberte, which is a producer of natural fragrances, we target the production of 250 kilograms of violet accord per year in order to be competitive with all the others. With all the other competitors, and to have an idea, an equivalent of our product but produced with chemical means, it is around 10 euros per kilogram, and an equivalent but with natural resources, it is around 350 euros per kilogram. And finally, for our marketing strategies, we choose the concentrated marketing strategy. And we position ourselves as specialists, and we focus on a single segment of the market. Then for the implementation part, we wanted to dimension a whole factory. So to do so, we constructed a flow sheet of the whole factory. I'm sorry, can you hear me? I have a problem with my laptop, so I'm here, but I think you can hear me, right?
Yes, we can hear you.
Okay, yeah. So for the implementation part, we wanted to dimension a whole factory, and as Thomas said, we dimensioned this factory based on the dry lab results. to be as close as possible to the reality. And this analysis allowed us to estimate an annual production cost of 1 million euros. And our project will cost 4,000 euros per kilogram of violet elixir. And you can notice it is very expensive compared with other means of production. But our process have many benefits. The first one is the reduction of CO2 equivalent we produced with our factory, because we are using cyanobacteria that can absorb atmospheric CO2. It has also a high traceability because we know all the ingredients that enter our bioreactors and what is. And finally, our product can be labeled as natural, which is a marketing argument, which is really important nowadays. And finally, for the implementation part, we also keep in mind the ethics and the future impact our production can have on the world. And to do so, we take sustainable developments into account in every step of our production. We also had a reflection on the use of GMOs, because GMOs can be problematic in some countries. And we also analyzed the impact of our production on other competitors, and mainly in small competitors. So that was all for the entrepreneurship part, and now Thomas will explain you the human practices.
Okay, so what's another important step that is divided in two categories is human practices. Actually, it's how we bring our project to the non-scientific, the companies, and all the the grand public. How to explain that, how to educate about synthetic biology also. So that's So what we do first is that we did a cyanobacteria symposium. We participate to it to talk about all the methods that we found and we developed and improved during our experiments with other team, because at this time there is actually strangely a lot of team in Europe that work with cyanobacterial consortium to produce many different chemical compounds. So we work with all of them. It's a third part. I will come with that. But yeah, we work with all of them to produce this book about cyanobacterial methods. So yeah, because what is very important into iGEM is a relationship between the team. Obviously, we are in competition with them, but it is really good when science is made with more than one team and we cooperate with them, and yeah, we exchange our experiments, and for good relationships. We made a handbook about all the phototrope for synthetic biology. So what we do also for the education step we designed a game we called really naturally Elixir the game. And so it's a game where the people that play with it have an education about recognizing the odor. We have, as you can see here, a lot of fragrances, and people have to find the fragrances to get points. And there is also a card with some synthetic biology question, main biology questions, and yeah, it's a really educative game that we bring to high school. And we also make them a short presentation about synthetic biology and what is the iGEM competition. And we also try to make this game accessible for people that have a problem with visually impaired people, so people that usually cannot play with board games. So we try to make it accessible for them, and we go to a specialized place and we ask for their opinion and their advice to develop a game accessible for this kind of public. For the end of the competition, as it was told before, we get the gold medals. So into the iGEM competition, So the gold and the silver and the bronze medals are not divided. It's not for the first, the second, and the 13th. Gold medals is a standard. So if you achieve all the requirements to have the gold medals, a mini team can have the gold medals. It's only about achievement. It's a really step methods to reward teams. So, but we were also nominated in some categories. So the best manufacturing project, because we were into the manufacturing project. We were also nominated for the best website, best video, best model, and best implementation. And as it was said, we won at the end the undergraduate grand prize. So we were really happy because we were really a small team compared to other teams. And so, yeah, we were really proud of us and really, really happy when we heard that. So I think it's the end of the presentation. Feel free to ask all the questions that you have, and yeah, we will kindly answer to it.
Okay. Wow, you guys did a lot of work in just 4 months. That's amazing. And yeah, I think we just heard a really cool project from iGEM Toulouse 2021. And again, if anyone would like to ask a question, you can drop the question at the link that are sent in the chat. And I don't think we have questions yet, but I do have a lot of questions to ask to both of you. But I think I mainly find it interesting that you're trying to shift from oil-based product, right? From oil-based economy to more of a bio-based product. And the approach that you use is this co-cultivation between algae with yeast. Do you think this is the way forward for synthetic biology to achieve sustainability?
Actually, there is many ways for sustainability, I think, in synthetic biology, because there is other teams also that work with some more cell-free systems, with only, for example, the not the mitochondrial, but all the machinery into the cyanobacteria that produce all the sucrose. So yeah, there is also this part of cell-free, but the co-culture is more and more seen as another way for to produce all those molecules. Where our main sponsor were really attracted by our results, and they try to lead this project at the end, because it's really it's a new way to produce more with more suitable manner the chemical compounds. Yeah, but this is not the only one.
Yeah, but I guess I guess it's still challenging, right? I mean, using the genome scale models, I think you found that you can make like half a kilo from 180 liters per hectare.
Yeah, but
I mean that's a lot, right?
That's a lot, but compared to the industry, actually, it's not that a lot. But what we used as a number and value, it was what has been shown already in the bibliography, into the literature, but it is not in the literature. It was not optimized for production at a higher compound. So there is many ways that we can actually optimize to get more and more of to increase the yield of production of our molecule of interest. We have many ways to interact with the enzymatic activity, and that obviously we don't have the time, because only 4 months is really too short to improve on the system.
I agree. I mean, but you did great, honestly, for 4 months. That's a lot of work. I might miss it during your presentation, but can you elaborate again how your in silico model inform your wet lab decisions? How does it be integrated? Does it help with the wet lab models?
Yeah, we have. Maybe Marco, you want to explain? Yeah, she lost her. Maybe she lost her microphone. She has a lot of. So I will explain. So we don't have a lot of time between the result of the dry lab and the wet lab during the summer. But the one really important that we found is that the way that the sucrose is really negative on the production of our molecules, and so we don't present it here, but we try to reduce the concentration of sucrose in the media of culture of the yeast, and actually we saw that we have in the end it was not for alpha but we have more production of molecule of interest. So it was the link between our dry lab and the wet lab. But if, for example, if the project has to follow and to continue, we will try to compare the results that we have for the prediction of the molecule of interest, the production of the molecule of interest that we have with the dry lab models, and also what we found in the reality, and try to understand why, if there is a difference between the model and the reality of the production, where does it come from, and everything like that. Yeah.
I see. Okay, that's really interesting. I still have a ton of questions, but I think I should give the time to our audience. So to all the audience online, if you have any questions, please unmute yourself and just go straight away. Or Tia, maybe you have somebody asking question in the Pigeon Hole. Do you have a questions there? Okay, so yeah, actually we do have a lot of questions already. So I'll just read along the questions that we have. So the first one, what's the biggest challenge that you face when you start the iGEM project? Maybe Marco or Thomas can give a comment on this.
You hear me?
Yeah, we can hear you. Go for it.
Okay, nice. The biggest challenge, I think it was during the summer when we conducted all of our experiments. It was really a lot of works, and we have to go on and to conduct all of our experiments. And sometimes we had the results we wanted, but we had to carry on. And
how many are you in the team?
We were 6 students, but we had a team of we had 3 PhD students that were helping us during the beginning of the summer, because we didn't know how to carry a PCR, like simple lab works. We didn't know how to do simple things, but at the end we were really independent, and really the experimental part is quite difficult, but yeah, you have to to carry on, and really challenging and lots of work, but it is worth it.
Okay, cool. Yeah, I guess the second question from the audience that I find it also quite interesting. If you're a new student and you would like to learn more about iGEM, do you have any suggestion on where to start reading the papers or the protocols? Is there anything that really helped you during your iGEM journey?
I think that we have a main website. If you, because was it resource for Church and Federal? Yeah, we have a main website. We don't talk about that, but you have to develop a WhatsApp at the end of the competition that is evaluated. And on this website, you just have to enter into your research bar iGEM Toulouse 2021, and you will find everything. So all of the related literature that we read is at the end of the page, especially in the results and the parts page. And so yeah, you can find any information in your website.
Yeah, and I guess the iGEM has a lot of resource also for learning, right?
Yes, I think few websites you can find some videos and some articles to inform you how to do something like, for example, for the entrepreneurship part, what is required, and for the dry lab, you can find tuto on the HQ main website.
I see. Cool. So I'll just read the next question. Do you use business for the entrepreneur part?
Business model canvas. Our main objective during the entrepreneurship part was to analyze a whole factory. So I don't think we built the Canva, but there are lots of many different documents and many different methods to that you can use in order to know how to position yourself and your project on the market. I think there are lots of resources.
Okay, cool. Yeah, adding to that question, I'm actually curious, what's your plan after iGEM? Did you get approached by, I don't know, a company or a sponsor to move your project further?
So in Toulouse, that we have to find our and so we had to talk with professional, and we find our main which is Roberte, and it is a main producer of natural fragrances, and our sponsor was really interested by our project because, as Thomas said, the violet is a mute flower, and producing a natural fragrance is really important for them. So Roberte gave us a lot of money to conduct our experiments, and at the end of the summer, they were really interested by our results, and they offered us a PhD opportunity, but unfortunately, none of wanted to continue the project. But yeah, it can offer really nice opportunity.
Cool. That's a really cool story. And yeah, there's this interesting question for all iGEM team, I guess. How do you end up together? How do you make this team?
So it's really depending on the iGEM team. So in our case, actually it's some PIs that organize each year the iGEM Toulouse team that make they ask to the faculty of science and the engineer school if there are some students interested into the iGEM competition. And so to enter into the team, we have to give them an idea of a project that can be applied for the iGEM competition. We have to present ourselves, what are also really important, what are also our other point of interest in life, what are our habits, our hobbies. So yeah, let's first select the team with this first screen. And after that, we have to bring them a really convincing project to say, okay, you can continue with this project. We can start everything, start the design of the molecular design and everything aside for the cloning, because it is a solid project. So yeah, that's the way that it works in Toulouse, and they try to make always not really big teams. Only usually it's 8 students for each post, really important, and yeah, to make sure that it's not too many students in the way that you're not thinking in a month that, oh, there is another student that can do that for me. I will let it for. So yeah, that's the mentality to lose, but it's really, really different in other teams. It's really depending on the team.
I see. And do you know how many times Toulouse has participated in iGEM?
How many times?
Yeah.
I
guess.
At least from the 2000 something, right?
2014, I guess. if I remember well.
Wow. Okay. Wow. Okay. That's that's cool. I guess you also get a lot of support, right? I mean, if you've been
our peer are really they give us really good advice. They never do what we have to do. They never code the wiki, but they said, oh, if you want to have this kind of answer, you should look at that. It's a really solid PI. Quite PI teams that are behind us. They, as also for the projects that don't give us a project, but when we have an idea, oh, you should maybe more look for that in your project to make it more solid and everything like that. So yeah, it's a really good supervisor team. Yeah.
Mm-hmm. Right. There's more questions from the audience. Can you share us about the software that you use in the lab and also for development?
I'm sorry, I didn't hear what you said.
It's the last question.
Okay.
Yeah, it's the last question.
For the wiki development, we code our website with HTML and CSS. It's a basic code, and you can find lots of tutorials online. And for the dry lab, maybe Thomas, you can answer more.
For the dry lab, we use Python to make all the models and all the algorithm. So yeah.
Is it Cobra for the genome scale model?
Yeah, it's Cobra for the genome scale model. And
to implement the what do you call it? The FBA, right? You're doing dynamic.
FBA, yeah.
Yeah. So do you write your own script for that, or are there any specific libraries?
So I was not in the really in the dry lab team of our project, but generally what is done in Python is that we have the keywords to find in the Google search bar already made algorithm or something like that. So to find some pre-made and adapt them to our questions. So I should ask for them, but I am generally it's work like that for when we have to design an algorithm with Python. Just looking if what is already done in what the other have already done.
Yeah, I'm just wondering if you or your team has this coding experience before, or you learn it on the job, especially for the wiki, I guess.
For the wiki, we were all novice for it, but HTML and CSS are languages that are easy to understand, and there are lots of stuff online that you can copy, like on our wiki. It's really open science and also open website. So if you really like something about another wiki, you can take it on the website code, and you can modify it
So if I don't have any coding knowledge, I don't have to worry, right?
No, really, for the wiki website, no, it's really okay. I didn't have had any coding experience before, but yeah, it was really easy to understand, and it is really worth it because you see what you're coding, you see it on the screen, and you see what is wrong, what is working, and it is really interesting.
Okay. Yeah, we have more questions. And Tia, just let me know if we still have a lot of time or we're running out of time, right? But I'll just go with the next questions. I think it's the last question on the screen. How long do you prepare for the iGEM competition? I know that the registration usually start in February. But what's the timeline for you guys?
So we formed the team in December 2020, and we begin the literature work and the brainstorm of what project we will choose. during between January and April, I think. And in April, we choose our project, so we choose Elixir. And from April to June, we build our genetic constructions. We research the literature about what molecules we can produce and so on. And between June and September, we were in the lab, so we carried out all of our experiments. And finally, but also during the summer, but between September and October, we code and write our website. And yeah, it was, but yeah, it was really nice.
I see. So I just have a question spontaneously. So what are your most memorable moments in iGEM? Is it the wiki freeze?
Good or bad moments?
No, I think for my part, the most exciting moment during this iGEM experience was in September. It was the last week we had in the lab, and we were only two.
Okay, yeah.
Yeah, we were only two on the lab because the other of the teams began school. So we were only two, and we had to run everywhere on the lab for finding GCMS, and finally we had this little peak of alpha ionon, and yeah, it was a really exciting moment. Like, it is the last chance for us to prove our project is working, and we did it.
Yeah, that's really cool. Okay. Any addition, Thomas?
I think that's the little peak of alpha ionon was surely the moment that we were really happy to see that, because it means that we achieve what we want to do in the end, even if it was really small. So we were really, really happy. But another part that I really liked was the moment that our supervisor team said, okay, we can stay with this project, because it was the moment of brainstorm was really stressful, because we were always giving some project, and yeah, it was super criticized that it's not interesting and everything like that. And we say, oh yeah, it's a good project, we can go with that. We were so much happy to hear that and to continue with this project. Yeah, and so I saw another question in the chat. How you guys deal with it? So yeah, it depends. So how guys deal with it? I guess you mean that how we deal with our study and the competition, right? Because yeah, for the team, we were all 6 students. We have the competition at the same time with our master degree or the engineer year school. And so it was for some period it was not really stressful, especially during summer, because we don't have any courses. The first period also was not really stressful because yeah, we managed our courses with the brainstorm and the design of the parts. But yeah, in the end, with the design of the wiki site, it was way more stressful, because the deadline was coming of more and more closer. So yeah, this part of the iGEM competition is more stressful. And then so yeah, it's really yeah.
Yeah, and I mean, it's still during the pandemic, right? Or after the pandemic? Do you still have restrictions?
So we were actually in our team, we were really happy, because our PI let us do the experimentation during summer with the 6 students in the same time in the lab. But I know from other students that who participated to the iGEM competition in the same year as us, that they don't have this chance. They were only 1 student, or sometimes they just close the lab for the experimentation, so they only have model projects for this year. So yeah, we were really lucky to be able to do the experimentation.
Yeah. And if I remember correctly, last year the Jamboree is online, right? Or do you have a meeting in Paris? It's online, okay.
Yeah, it was.
Was
And how
online.
do you feel? Yeah. Right.
They were local little jamboree.
I
But
see. Okay.
we choose to stay in Toulouse with our PI and with our team.
Okay. Yeah. It's I guess it's a different feeling. But do you feel jealous that you will have the first iGEM Jamboree in Paris in person this year?
I think it's a really great experience to have the jamboree not in line. I think you can measure your work and you can compare your work with the other team. You can share your experience, and I think it is something on our team. We were all looking for this kind of experience for iGEM, but yeah, because of the pandemic, we were a bit sad that it wasn't. Yeah, we had fun with our team and with our PI in Toulouse also. So I think it's great, but if you can do the jamboree in person, it's even better.
Yeah. Okay. So yeah, I guess questions keep popping. What are the take-home lessons during this iGEM journey? So I guess it's a question to both of you.
I think teamwork is really important and collaboration. You have to speak with lots of scientists to carry out a real project. You have to take the experience of so many people to have a project that can work and that can be real, can be done. Yeah, teamwork is really important. You have to communicate with your teammates and with other scientists.
I see. And anything from
me
you?
For me it is motivation and fun. You have to be motivated if you want to participate, but it's really a funny competition. There is many things that you can do outside of science. So yeah, it's really a really good competition. I advise it if you're motivated enough.
So I have a question to both of you. If you can return back to the time when you started the project, do you want to do things differently? Do you want to do it with other people?
Maybe have some more people with us in the team because it was really a lot of work. But I think we did pretty well, and yeah, I'm happy with all that we have done. I think I didn't change anything.
Yeah, we not changed a lot also. Yeah, maybe more people because it was we were working a lot. So, but it's but maybe because we were a little team, it was really friendly between us because. So maybe I will not change a lot of things also.
Okay.
Yeah, we are really close, and this hard work really get us together, and we formed a really strong team.
Okay, yeah, that's really cool. I don't know. I think we have all the questions answered, or did you? Oh yeah, there's a question in the chat. What's the current team is working on? Can you give us anything, or is it still a secret?
No, I think they shared their project on Instagram, so
okay.
We can talk about it. They are focusing on I don't know the English word for allergy.
Allergens.
Oh, allergens.
So they are trying to diagnose some allergens molecule with some bacteria, with some sort of antibody at the membrane, and they start to coagulate around the allergen, and that way to do some diagnostic tests.
Wow, that's a totally different project than you guys.
Yeah, and that's a really good part that we really like in Toulouse. That RPI let us free about to design a project. They always said, we will never give you a project. You always have to bring us a project. So the project is really different between one year and another. So it's really, really cool.
But I guess you always have the same PI every year, or is that depends on the team?
We have a main core PI, so generally it is, we can give it his name, it's Brice Angelbert, that is always the main PI. And generally, there is other core PI, like now Ambre Jousselin, Cédric Montagnier, some names. But when we start to focus on one topic, as I try to find some other researcher, scholars that work with that kind of topic to give their advice on our projects. And yeah.
I see. Oh, that's cool. So yeah, you bring your own project. That's really cool. And I'm just wondering about you two. I guess both of you has graduated, or are you still in the? You've already graduated.
Yeah,
do you plan to stick around in iGEM? There's a lot of after iGEM opportunities, right?
Yes, we are both graduate now, and yeah, I'm looking a bit about after iGEM, but I want to do a PhD, so maybe in the city where I'm PhD, I will take part on the iGEM team of this city, but yeah, I don't think I will. I will take part after iGEM. Yes. If you want to.
And for my case, I will try to do as Margot, but the problem is that the town where I do my PhD, there is not iGEM team that are presenting. So, but I try to maybe I will try to convince my PI to maybe start the PI of iGEM team, because he was a supervisor, one of the first supervisors of the iGEM team into Boston, but he stopped that because he moved. But yeah, I will try to convince him to start again to be.
Okay. That's really cool. Yeah. It's always fun, right? I mean, after the iGEM, you still have the network that you build. You have the connection to your PI and other scientists. So
yeah,
I guess to all the audience.
It's a really large competition, because when I do my
chance to join iGEM, please.
Because when I do my internship for the end of my master degree, in the same team as us, we have me. I have another internship student that also made the iGEM competition. So yeah, it's really large. You met a lot of people, and yeah, it's really you learn a lot.
I see. Okay, Tiara, how are we doing with time? Do we still have?
Yes.
Yeah. How much time do we have?
It's okay, but because all the question is done, right?
Yeah, I think I'll just give one more chance to the audience. If you would like to ask questions, just raise your hands. I see one raised hand here. Sanka?
Hey, iGEM Toulouse, thank you so much for the presentation. It was amazing to see this kind of project from iGEM. I was in iGEM Uppsala 2017, so I know the feeling and then the vibes and everything, but you guys did a lot of works compared to ours. I mean, it was amazing. It's just out of the topic, and curious how you stick the team together. Basically, do you have any other kind of activities that support this kind of what you call it, to get these
together
along, right? Because that's one of the hardest part when you compile or like gather lot of people from different backgrounds within different teams, and sometimes you split them into different lab groups as well, right? So how do you kind of stick people together and make them stick around?
I think that's a good question. We had we made a lot of parties, and for example, every Friday, no, not Friday, but every Saturday evening, we were all gathering together to eat something together, to talk and to talk about everything else but the project. So yeah, I don't know. We were really close because of the hard work. I don't know how we managed to to be friends for during the summer and so on. But yeah, we managed it and we were very happy. I don't know, Thomas, if you did something special.
I think that's the Saturday. I think it's a Saturday party. Yeah, no, yeah, but we also, but it was not only about science. We communicate on many fields, and you start to see that you have a lot of common points with everyone. That so when you start to interact a lot with some other people, you can be really friends in the end. So yeah, I think it's multiple things, and yeah, I think also it's a small number of people also because we were six. It was more easy to us to talk with everyone, and so on. Yeah.
Okay, thank you. Yeah, that's why I like I was curious about this one because here there's some let's say competitors that are going to buy us or this competition, bioinformatics and synthetic biology competitions, and maybe they have the similar kind of problem to kind of encourage each other. And this is good that you suggested some activities that might support these what is it, team building, right? Okay,
Yes.
thank you.
Oh, that's a really nice questions. And I don't know, do we still have more questions from the audience? Let me check in the chat or... Okay. Yeah, I think we have all the questions, and thank you for Thomas and Marco. It's really inspiring to hear the stories from you guys. It's always inspiring to hear stories from iGEM teams. And yeah, I hope we can connect again in other opportunities. But I hope that today can be an inspiration to you all. And well, I guess most of you are still in the undergraduate or just start a master degree. If you have a chance to join iGEM, please do. And yeah, I guess let's give a big applause to both of our speakers today.
Thank you.
Thank you to invite us.
Thanks, and I'll give back the session to Tiara.
Okay, thank you for Mr. Mastin for being the moderator for the talks today, and thank you very much for the speakers, Thomas and Mark Hawks from the Toulouse team. And don't forget, guys, before we ended this talk, maybe for the documented, so maybe of all of you guys to open your camera because we're taking picture before to end this talk.
Group picture. I think both of us still pin.
Okay, maybe for team to unpin the off. Okay, guys. Yes. Because so many people that can't open the camera. Guys, let's open your camera. because we will take the picture for the documented this talk. Okay, maybe for team, let's do that. 1, 2, 3. It is the guidance. And then next, because there is 2 parts. 1, 2, 3. Okay. Okay. Thank you for the Thomas and the Margot. Merci beaucoup from here in the Synbio Talk team. And guys, we hope that all information and explanation can gain insight about the iGEM. And closing maybe for me and team for today. Thank you very much for all, and see you in next Synbio Talks again.
See you.
Thank you, good job.
See you. Thank you so much.
Yeah, merci beaucoup, everybody.